Welcome. This is lecture 37, part 1. Very important concept. That is couples. I told note very important. For that matter, everything is important. Those who are serious about learning, everything important. Okay. Now, just some see. Now onwards, what I will do is, too much of statements all in the board I am not writing. Those who are going to the class and want to depend only on the class, what they have to do is, they have to listen correctly, somewhere they have to stop in between and write all these things. Little effort from you also. You cannot get everything so easily. So therefore, what I tell, some statements all, I will dictate. I won't write. It takes lot of time. Already, this is class number, I forgot now, see, 37. Mechanics, lot of classes are pending. If I keep on writing each and everything on the board, then it will become very lengthy. No, those who want to learn, little effort from your side. Otherwise, there is no other way. See, no other way means you cannot learn. If you cannot make all the notes and write systematically, you cannot learn. So, some work for you also. But remember, in the notes, I will write each and everything because it's my commitment. Okay, start now. Couples. First, consider some statement. Consider a body. See, I am not writing here. Don't see there. You start from here. Consider a body subjected to two equal, unlike, parallel forces with different lines of action. Very important. Two equal, unlike, parallel forces with the different lines of action. See, these are the parallel forces, one parallel to other. If this is up, this should be down. Why? I told two equal, unlike. Unlike means what? See, like, I write one more sketch here. Make a note. Consider only two forces. Okay, see. Only two forces. Parallel forces. Down. Down. Both are parallel to each other. So this is a parallel force system. Both are equal. See, P and P. And both have same direction. This is called like parallel force system. Like parallel force system. Unlike means some of the force in a system, here only two forces are there. If multiple number of forces are there, unlike means the direction of some of the forces are opposite to other forces. So if only two forces are there, if this is down, this should be up. Or if this is up, this should be down. See, P equal. So remember, two equal, unlike parallel forces. Parallel forces. Still incomplete. See, suppose I apply a force here and force here. P and P. See, are they parallel? Yes, they are parallel. A line is parallel to itself. See, if you draw a line, if you draw one more line to the same line, they are called parallel, but looks very odd actually. Still parallel. So they are parallel. Equal magnitude. Opposite direction. Still, it won't come now. But they have same line of action. See, this is the line of action common for both. No, this is not our discussion. So I told two equal, unlike, parallel forces with different lines of actions. Lines of action. Very important. Different lines of actions. Or you can tell two equal, unlike, parallel forces separated by a distance. If you want, you can write that way also. One more language. Separated by a distance. You consider that force system. Now see, I'll write here. I'll go to one by one example. See, start. First consider figure 1. Figure 1. See, this figure you have to write here now. Remember, not there. I wrote everything for easy, for saving the time. First what you do is, this figure you write here. If you are serious, you write. If you are not serious, do whatever you want. Okay. Write the figure here. See here. Write statement. P equal. They are parallel, but they are unlike. One is going up, other is going down. Yes, this is what we are discussing. Now see what happens. Here, if you want to find resultant force, the magnitude, you should write everything here. You put that sketch here and write. Here, the magnitude of the resultant force equal to, if you take anything positive, P plus P or minus P. If you take this as positive, P upward, P downward. Like 100 rupees income, 100 rupees came, 100 rupees spent, net 0. So resultant force equal to 0. I want this red color. Resultant force equal to 0. Just because resultant force is 0, never come to the conclusion direct blindly that, oh, this is in equilibrium. No. These two parallel forces, even though resultant is 0, it won't be in equilibrium, or resultant force is 0. I never told resultant 0. Just now by mistake I forgot to use the word force. So change it. Not a mistake, forgot it. Resultant force equal to 0. But resultant is not 0. I told long back earlier, if resultant force is 0, it does not mean that resultant is 0. This we have covered earlier, but concept will come now. Now the concept will come. So if resultant force vanishes, it does not mean that outrightly resultant is 0, because if resultant force does not exist, resultant can exist in the form of a couple. See, resultant force means translation, resultant couple means rotation. So right here, resultant force equal to 0. But see here, if you apply one force up here, one force down here, this body on which it is acting, it will not be in equilibrium, even though resultant force is 0. So resultant force 0 means the body will not have translation. It will not move. But everything you are right here. But it will rotate. See here. You see here. You take something here, apply upward force, apply downward force. See, it will rotate. Therefore, the body will have only rotation. Such a force system where resultant force vanishes, but there is rotational effect. This is called, the system is said to have formed a couple. Therefore, you can put definition of a couple now. Couple definition. Again, I won't write. Time will take a lot of time. See, slowly I am telling. For those who are writing, seeing the class, two equal, unlike parallel forces with different lines of action, or you can tell in the bracket, separated by a distance, will form a couple. Definition you write here. But in the notes, not that way. I will write each and everything. I will put the sketch here and write. See, there, because it's a commitment. When I give a notes, it should contain everything. Others, those who are depending on the class, you have to do some work. I decided now. Now onwards, will not write too much of statements all in the class. I will dictate. So much effort I am putting, some effort you also put. See, everything you will not get very easily. Some struggling required. Okay, now, I already told two equal, unlike parallel forces with different lines of action, or in the bracket, separated by a distance, will form a couple. Okay, right. Now, when a force system reduces to a couple, then there is no resultant force, only resultant couple or moment. So therefore, the effect on the body is not translation, but rotational. Now, 1 minute, you leave it now. See, I'll give more example for you. Imagine, see, there is a tap. Everybody knows what is tap. You want to open the tap. See, if you do this way, you are closing. If you want to open the tap, what you will do? Tap here. See, some will tell, what you will do? Sir, I will turn. No, you are not turning. Actually, you are actually turning, but you are actually applying a force. See here, by finger, what you do is, by some fingers, you push up, other finger, you push down. See, you are applying two equal opposite forces, two equal parallel opposite forces in opposite direction or unlike parallel forces you are applying. See here, suppose this block here, see. If I apply randomly, it will move. Now, I will apply upward force here and downward force here, slowly, see. This way. It will rotate. It won't move. It will only, see, I will apply force this way. I will apply force this way, see here. As I move again, force will be, see, now it will be like this. Now it is like this way. Or imagine you know how to drive a car. Steering wheel is there, this way. Suppose you want to turn the car. What you do? Sir, we will rotate. What? You are not going to rotate the wheel. You are having a steering wheel with you. With one hand, you will pull, you will apply a force towards you. Suppose you want to take right turn. One hand, you will apply a force towards you. Other hand, you will push it away. See? This way. As it moves, rotates, again this way. See? This way, this way. So, two equal unlike parallel forces you are applying. As a result, steering wheel will rotate. As the steering wheel rotates, what happens is the wheel will rotate. That is mechanical, not civil. So, unknowingly, you are not applying a couple. See, suppose I am rotating here. See, some will tell, I am applying, no, I am not rotating. See here, see the finger here. I am not rotating. I am applying a force only. But the force results in rotation. There is no translation, only rotation. So such a system of forces where translation is prevented but rotation is allowed, that is actually couple. Further, so many examples we can give. In the steering wheel, somebody asked a question to me. Sir, sometime what people will do is, that I also will do. When you drive a car, you don't use both the hands. You usually, one of the hands, you rest on the window. I do it. See, one hand will rest on the window, you turn the vehicle, steering wheel, by only one hand, this way. In India, we are right-hand drive, see, you will drive this way. Then, sir, where is the other force? Correct, good question. So, you are forming a couple with only one force. No, there also unknowingly, you are applying two equal, unlike parallel forces. See, I think you know it. Usually people drive like this. Sometimes I make fun. People drive like this. Somewhat looks amateur. People with good driving skill, when not in heavy traffic actually, not in a jam, emergency, they see what, both hands they will use. What you call casual driving all. They put their hand on the window and use only one hand. So, note, even if they are using only one hand, unknowingly, they are actually applying a couple. They are actually producing a couple that is two equal, unlike parallel forces. Where is the other force? Question for you. Answer. This question I will ask in the brain teasers. Small question. Sometime in the class I give the answer for that one. Not difficult one. Very simple. But I will ask them, is it easy or difficult? Sir, little difficult, sir. Yes, little difficult. See, one more thing. As the steering wheel is bigger and bigger, turning is easy or difficult? Sir, easy. Yes, correct. See, or if you want to remove some screw from a vehicle, see, as this arm becomes, you are applying a force here and rotating. As you apply more and more, as the distance is more and more, what happens? Sir, effort will become lesser. Yes, reason is there. This all I will tell you later, not right now. So right now, remember, two equal, unlike parallel forces with different lines of action or separated by a distance will form a couple. Okay, now start. How you consider or how you measure the magnitude of the couple? See, first remember, when a force system creates or forms a couple, then resultant force equal to 0. there is no resultant force. Now, there is no translation, only rotational effect. Okay. Here I am dictating little, whatever comes to my mind when I write the notes, I will think of a well-judged statements all, a systematic way, because why? I am casually sitting and writing. Here, what comes to mind? I never come to class prepared. I casually came here taking the class. I never bother any class, what I have to do today. I just see previous class, what is done, and start. Okay. Then the resultant force equal to 0. Now, when the system is, right. For then, when a couple is created, or when a couple is formed, the magnitude of couple is also called moment of the couple. Now see, I will tell one by one how to find moment of a couple. See, I will write here. Moment of a couple is equal to see, product of any one of the forces. Any one, be careful, any one of the forces and the perpendicular distance between the two forces. Any one of the forces and the perpendicular distance between the two forces. And direction for couple depends whether the rotational effect is right here clockwise or anti-clockwise. Don't write arrow mark. If you want to learn correctly, write clockwise, then put arrow mark here. Don't write symbol, clockwise or anti-clockwise. Everything will now be explained for each and every example, right? Now, he will explain everything for each and every example. What you have to do is, each time in this one by one, if you want one thing, first you write all the sketches, then start. First, figure 1. Consider figure 1. Okay. Figure 1. See here. You write this figure here. Or for that matter, right here, in all the 6 figures, the 2 equal unlike parallel forces are there. Perpendicular distance between them is A. So, magnitude of each force is P. One of the force P is opposite to other P. But before that one, both the forces are right here, common to all the 6 figures. P and P are the 2 forces. They are parallel, that is P and P means equal, but direction wise opposite, though equal unlike parallel forces. Let A be the perpendicular distance between the 2 forces. See, suppose you take one point here, you should go to perpendicular here to the other one. Okay, now every one same statement. Now start. Consider figure 1. Just now I told, he right here. Just now he told. Moment of the couple is, I will not tell again and again, couple equal to what? Product means what? He told product of any one of the forces and perpendicular distance between them. That is magnitude of any one of the force. Both are equal. Magnitude of any one of the forces. Multiplied by perpendicular distance between the 2 forces. Therefore, for figure 1, moment of the couple, I write here, for figure 1, moment of the couple equal to any one of the force. Which force? Any force equal to P multiplied by distance A. Now, if you observe here, see, you take moment about this point. See, P, if I take, you make a note there. If I take moment about a point in the left side force, other force moment is P, other force is P into A is clockwise. I will ask a question in the class. See, if I take moment about this point is clockwise, other force if I take moment, instead of clockwise, it will be, all will tell, sir, anti-clockwise. Suddenly some will tell, sir, no, sir, sorry, sir, that also clockwise. Yes, it hardly matters. You should write each and everything. Whether you take moment about any point on this line or this line, whichever line you take, direction will be same. See here, if I take here, right, you should write, if I take moment about only for, see, I'll take one point O1 here, one more point O2 here. Right there, if you want. If I take moment about the point O1, this P into 0, other P into A is clockwise. See, clockwise. Or, if I take moment about O2 here, again the force is P into A, once again clockwise. So, irrespective of whether you take moment about any point of the left side force or right side force or here, upper force or lower force or this force or this force, whichever force you take, direction will be same. Or that much difficulty is not there. You can decide by feeling. See, feeling, see here. See here. Clockwise. Therefore, it is P into A clockwise. Right here. Okay. Before that you write resultant force equal to 0, moment of the couple equal to P into A clockwise. Okay, now do one thing. This all not required. Right. Or now do one thing. You write this figure once again and tell this system is actually will give a clockwise couple of P into A over. Once again right here. The red color is the final answer. This force system, or then you can do one thing. You make this dotted line and tell dotted line. Finally, the effect of these two forces is to create a clockwise couple of P into A, enter there. Okay, now, little fast I will do. Right, consider figure 2. Figure 2 here. Same as figure 1. Here left up I written, left down, right up. Right there. Here also resultant force equal to 0. Why? Down P, up P, 0. But couple will be, see, if I take moment about this point, about any point here, P into A anti-clockwise. Or if I take moment about this point, once again, P into A anti-clockwise, or that much not required. You hold the pen here, apply upward force, downward force. See, you can make out. It is P into A for figure 2, right here. Figure 2, it is P into A anti-clockwise. Then do one thing. Write this sketch figure 2 once again there. Make this P dotted line and tell this is equivalent to a couple of P into A anti-clockwise. Right, next. Figure 3. See, in the notes I will do one thing. Each one write separately. Figure 3. One of the force is horizontally right side. This here I took two vertical forces. See, there is no rule that to create a couple of vertical force required. They should be parallel to each other, equal magnitude. See here. A right side force P, left side force P. So resultant force equal to 0 and couple equal to any one of the force P into A. See here. P, if I hold here, see, this way and this way, if I apply, oh, clockwise. P into A, clockwise. So this one, you make dotted line, put one more sketch and tell equal to a clockwise couple of P into A. Come to figure 4. Same way, resultant force equal to 0, make dotted line, moment of the couple is P into A, but this time, see here, this way, anti-clockwise. Seriously learn. Here, Forces are neither horizontal nor vertical, but they are parallel. See, if this angle is theta, this is also theta. Otherwise, it is not called parallel. Now see, if I hold here, resultant force equal to P minus P equal to 0. Find the force in this direction. This I told you for parallel forces. Resultant you find in that, along that line. 0 you should write here. And couple equal to, see, if I take here P into A clockwise, if I take here also P into A clockwise, or feeling, see, hold the pen this way, see. So therefore, it will give clockwise couple, make dotted line, clockwise couple of P into A right there, clockwise, okay. Lastly, write figure 5, I forgot to tell, figure 6, write this figure once again and tell couple is P into A anti-clockwise. Therefore, remember, now onwards, I will not tell again and again. Only once I will tell now. I am rubbing the board now. When you want moment of a couple, what to do? See here. Final warning, because people who do not listen to warning and forget everything, you are losing. Moment of a couple is how couple? Formed by what? Formed by two equal, unlike parallel forces. Parallel forces with different lines of action. Different lines of action. So moment of a couple is equal to magnitude of any one of the forces. Not both. Never blindly write P into A plus P into A. It is nonsense. Magnitude of any one of the forces, but note, only one force. Only one force. Which force? Any one of the forces multiplied by, because this principle you write right here, into perpendicular distance between the two forces. You make a note here. How this came? This came by taking moment about either this point or about this point. Moment about a point lying in line of action of any one of the four. See, if I take moment about a point in this line, in the line of action of this force, then this force into 0, other force into P, so P into A. So that's why simple language, in future I will tell, if a couple is formed by two equal unlike parallel forces, moment of magnitude or moment of that couple equal to any one of the forces. See, I am telling, warning, any one of the forces multiplied by perpendicular distance between the lines of action of the two forces. Now, one small hint for you. Remember, in RCC, see, think a little. Suppose there's a RCC. Whether you do working stress or limit state method, finally you get a resultant compression force here, C, a resultant tension force here, if it is sagging beam, T. This lever arm I used to call earlier A. Some people call Z. This will create a couple because your C equal to T. C equal to T. Because by resultant compression, equal resultant, little earlier. Okay, now, moment of this couple M equal to, it is not C into A plus T into A is utter nonsense. Nonsense. What summation? No summation. Instead, moment of the couple M equal to either C into A or T into A. Remember RCC? In RCC, you don't write C into A plus T into A. You write C into A or T into A. If it is limit state method, C into A will give you 0.36. The limit state method, as per Indian code, 0.36 FCK point is fck into b into xu into d minus 0.4 to xu, whereas if you take t into a, you will get 0.8 on fyast into d minus 0.4 to xu. Don't worry, as we see. I have told those who are knowing RCC, otherwise leave it. So it is moment of the couple equal to, see, first of all remember, C into A, it is either C into A or T into A, because C and T are equal. It is same as P into A. P into A. Don't make C into A plus T into A complete utter nonsense, adding the two moments. Because when you take moment about any point here, that force into zero. Or now we will prove some important concept for the couple. And one more thing I forgot now, regarding unit, I should not tell. See, it is a moment. A moment is always force into distance. Therefore, dimensionally, F into L, like Newton millimeter, Newton meter, kilonewton millimeter, kilonewton meter, etc. Not per Newton millimeter, Newton meter, kilonewton meter, force into distance is the unit. Now, see, earlier I introduced some couple. If you remember a question I solved earlier, see, there was a couple here, I don't know how much, a couple M given here. When you take moment about this point, if a force P is there, you wrote P into some distance. For M, you simply wrote M, no into. Why? It all will come now. It is called sometime properties of couple or characteristics of couple. I will explain one by one in correct order after making the board ready for that. Wait for the inside. What wait? I will pause and restart. You don't have to wait. You have to wait for me to go to the camera to pause and again come back here. Few seconds only. Now we will consider characteristics of a couple, or to understand better some important concepts for couples. That is much better. Properties or principles, whatever you want you can call. See, as long as you understand subject. Which words are used does not matter. See, basic concept, fundamentals, etc. People sometimes tell basic concept, sometimes tell fundamentals, sometimes tell principles. All one and the same. Okay, start now. There are total 6 properties are there, 6 characteristics. This contains everything. One by one I will explain. See, first, 1. A couple is formed by 2 equal unlike parallel forces with the different lines of action. Yes, this is already over. Right here, already over. No more statement. That is this here. We write everything with the couples. This is as per basic definition. Okay, second one. Algebraic sum of forces forming a couple is 0. That is, for a couple, there is no resultant force. This also already over. Okay, now these two are over. Come to third one. The third one is the most important property. This is the most important. That is, moment of a couple about any point in its plane is constant. About any point in the plane is constant and is equal to moment of the couple itself. That is the basic definition right here. That is the basic definition. Space is not there. Moment of a couple about any point in the plane is constant and is equal to moment of the couple as per the basic definition. That is product of any one of the forces. I told any one of the forces and perpendicular distance between the two forces. Okay, this requires little discussion. See, now I'll come to, you do one thing. These two write this one and then tell more statement and also proof. 1 minute. Camera, I have to check. Have I gone below the line? No. Okay. So for you, this all you don't go here. You write this much and come this side. See. First of all, consider. See, what I am doing. I am extending 3. I am extending the point number 3. See, you don't write anything, any of this one now. Write 1, write 2, write 3, and then come here. Don't see this one. Okay, 3. Consider a couple. You should write formed by two equal unlike parallel forces. Okay, with different lines of action. For example, say I want clockwise. Okay, anything will do. One upward force P, one this side right here, one upward force P, one downward force P. Anything you can take one right side force, one left side force, one force like this P this way, or even downward and upward, whatever you want. Okay, P, distance A apart. Couple. As per basic definition, moment of couple equal to what? Magnitude of any one of the forces. Before this I told, how many times I told? Any one of the forces and perpendicular distance between the two forces. That is equal to any one of the forces P multiplied by A. See here, clockwise as per this example is the answer. Now, some extra statement I will give you. 1 minute. I am checking right hand side. Has gone out of camera. No, because sometimes I get doubt. There's a small dot mark there. Up to there I can go. Still I get doubt. If camera turned, later I can't record once again. See, now, make a note here. How this result came? First of all, the basic definition. That is, remember, any one of the forces multiplied by what? Perpendicular distance between the two forces. For example, see, 10 and 6. Moment of the couple equal to 10 into 6. Either this 10 or this 10. Do not write 10 into 6 plus 10 into 6. Any one of the force into distance. Okay, right. Now, how it came, I already told. This came by taking moment about any point lying in line of action of any one of the force. See, for example, if I take a point here, say O1. If I take a point here, see this point O1. If I take a point here O2, then moment if I take about O1, okay. If I take moment about O1 equal to this P into 0, which you are taking moment about which point which lies in which of the force, that force into 0. So here P into 0 and then P into plus P into A, see, clockwise. So answer is P into A clockwise. Or if I take moment about O2, here, see, this is what P? This is your, I'll do one thing, left side P, this is your right side P. If I take moment about this force, it is once again P into A, see here, P into A clockwise, which P? Left side P, clockwise, plus one more P, which P? Right side P into 0, once again P into A clockwise. Therefore, there is no need unnecessarily of to get the moment of a couple, consider a point in any line of action of any one of the force, then take moment about that point, which force, in which line of action you take, that force into 0, other force into A, distance will come, not required. That's why basic definition is simple language, moment of, you write here, moment of a couple is equal to product of any one of the force and means product into perpendicular distance between the two forces. You write and understand thoroughly forever. Okay, now, 1 minute. This is I am removing. Now, question will come. You took moment about this point or moment about this point. 1 point about O1 lying here, 1 point about O2 lying there. Can you take moment about any other point? Very much. Unnecessary asking for trouble. Okay, now, the statement is moment of a couple about any point in its plane is constant and is equal to moment of the couple P into A. So, directly write here, moment of this couple, moment of the couple here as per basic definition. See, I am telling repeatedly, equal to P into A clockwise over. Now I will not tell much. Okay, now write here. Now, can you take moment about any point? Yes. Because see, now do one thing. Now, once again consider the force here, P. Right here, P upward, same force. P downward. P downward. Okay. This distance is A. Okay. Take a point O1 here. Take a point O2 here. Take one more point O3 here. Take one more point O4 here. Take one point O5 here. All in one line. O5 here. This distance, take whatever you want. Anything you want. A, B, C, D, E. E1, E3. Something. A3, E3. Okay, E3. O4, you take E4. Eccentric. Okay, E4. For O5, some distance required. Okay, from here to here is E5. Some randomly, E5. Can you stop? E1, you can take some other symbol. Okay, do one thing. Okay, leave it. Okay, now start. Instead of 1, 2, 3, 4, it is better to take some other number. Okay, not E1, E2, E3, 4. See, let it be A, so one thing. Let it be B, let it be C, let it be D. Okay, that is better. But remember, original definition P and A will come. So I will do one thing now. That P into what you require is see, red color P once again. Distance is A. That's how you got moment P into A. Okay, now do one thing. Take moment about M, moment about, you write not M, write moment, find moment about O3. Answer, see here. P into B. It is anti-clockwise. Right here. Don't put plus minus. Don't write plus minus. P into B anti-clockwise plus P into B plus A. B plus A clockwise or equal to P into B anti-clockwise plus P into B clockwise plus P into A clockwise. Oh, PB anti-clockwise, PB clockwise, these two will cancel. Why? One of them is anti-clockwise, other is clockwise. Any one you can take plus and minus. This will cancel. Finally, answer equal to P into A, that is clockwise. That is as per the basic, right here. That is as per the basic definition only. Right, next. Take moment about O4. Okay, try. Take moment about O4. Answer is here. P into A plus C. This is D I told. P into A plus C. See here. P into A plus C is clockwise. Then anti-clockwise. Plus only you are right. One more P into C, that is anti-clockwise. No plus minus or equal to P into A clockwise plus P into C clockwise plus P into C anti-clockwise. Oh, P into C clockwise, P into C anti-clockwise will cancel each other, will become once again P into A clockwise. That is as per the basic definition. Next, moment about O5. See, P into D. P into D clockwise. Then plus once again P into, this is D means this is A, this is A minus D. That much you should be knowing. See, P into D clockwise, that also is clockwise about this point. Clockwise, clockwise, P into A minus D are equal to P into D clockwise plus P into A clockwise minus P into D clockwise. See here, P into D clockwise, P into D clockwise, one is plus, other is minus. This will cancel, or that way, P into D plus P into A minus P into D, these two will cancel, or again will become P into A clockwise. Therefore, right here, moment of a couple, magnitude of what I am telling, you should write now. In the notes I will write. Magnitude of moment of a couple you can find by taking moment about any point in the plane. But you have to consider both the forces then of the force system forming the couple. Any point in the plane, but it is constant. Whichever point you consider in the plane, finally your answer will come product of any one of the force and perpendicular distance between the two forces. Therefore, instead of wasting time every time, take moment about there, take moment about here, not required. Right here. Therefore, instead of wasting the time in future, see, if a couple of this type comes, moment of the couple equal to any one of the force P into A over clockwise. That way, right. Right. Now, important concept. See here. Suppose there is a force here, a P. This is not that P. I'll do F actually. F, okay, force F. And a couple M. Couple M. This is M is a force, M is a couple. You take points here. A point O1, a point O2, and a point O3. Moment about O1 we want. Moment about O1 equal to, suppose I tell this as X1 and X2 is F into X1, F into X1 plus just M, that's all. No distance. Because moment of a couple, you know about any point is constant equal to M. Now, moment about O2 equal to, see this F into X1 is what? Clockwise. M is clockwise already, clockwise, okay, about this point. F into X2, side will use later, anti-clockwise, then plus M, clockwise. Moment about this is O3 I wrote, okay, O3. O2 equal to F into 0 plus M clockwise, or make a note here. Now I will give a warning note, you write yourself only. When you want moment of a force, multiply the force with the perpendicular distance. I will not tell again and again. Red color right here. This you already know it. Moment of a force is force into perpendicular distance. But if you want a moment of a couple about any point, no multiplying, nothing, moment about this point, M, moment about this point, M, moment about this point, M. That is the reason, see, long back we solved a question, if you remember, where I put a couple here and couple here with plenty of forces. You make a note here. I don't know what type of forces are there. A, B, C, D. Say for example, 60 Newton meter. This is 50 Newton meter. Now, when you take moment about A, or moment about B, or moment about C, or moment about D, right, for different forces, you multiply force into distance. But when you consider couple, suppose you take clockwise positive, then whether it is A, B, C, D, whatever you take, plus 60 minus 50. Plus 60, see, about A, plus 60 minus 50. About B, plus 60 minus 50. no into. About see, plus 60 minus 50. About this also, plus 60 minus 50. Or when you find moment about any point for a couple, no multiplying, wherever is the couple, answer is whatever is the couple, that's all. Clockwise, based on sign convention, if you take clockwise positive, I will tell plus 60 minus 50. Example. So this is a proof for this one, moment of a couple, over. Now, closing part. A couple cannot be balanced by a single force. Instead, it can be balanced by another couple of same magnitude but opposite direction. Some logic required. See, suppose imagine I am applying a couple this way. Someone was telling, it is disturbing somebody. Hey, why are you disturbing me, rotating? Stop it. I won't stopping it. I will apply. He will ask somebody else, go and stop it. If he tries to stop it by applying a force, what will happen? See, instead of rotating here, it will move somewhere and again rotate. So, when a couple, if a couple is to be balanced, it will be balanced by another couple of same magnitude but opposite direction. See, or if somebody is rotating there, someone is rotating here, you want to stop it, not by a force, you go and rotate in the opposite direction. So, simple one, a couple cannot be balanced by a single force. Instead, it can be balanced by another couple of same magnitude but opposite direction. Fifth point, the resultant couple of a number of coplanar couples, for example, clockwise 100, anticlockwise 80, clockwise 60, anticlockwise 40, clockwise 30. Just all are in Newton meter, imagine. The resultant couple of a number of coplanar couples is a single couple whose of magnitude equal to algebraic sum of moments of all the forces. So, the resultant couple equal to resultant couple equal to, if you take clockwise positive, plus 100, minus 80, plus 60, minus 40, plus 30. That's how you find. So, when you want to find, when multiple couples are there, if you want to replace by a single couple, the magnitude of the single resultant couple is that couple whose magnitude is equal to algebraic sum of moments of all the couples in the plane. Okay. Last one, any two couples of same magnitude, same moment and direction are equivalent. See, this is my way of, actually IRR, that's all. Actually, you're right. Irrespective, I am telling because to stress the point. Irrespective like that. Irrespective of magnitudes of the forces and also direction forming the couple. I will tell you what is that one. See, suppose a body is there here. Take another body. You apply a force this way. 100 Newton. A downward force of 100 Newton. Distance is 20 millimeter. 20 millimeter. Moment of this couple equal to any one of the force 100 into 20 equal to 2000 Newton millimeter. So this will be clockwise. Now you can consider another couple. How? Randomly. This way, any direction. See, this is clockwise, correct? Okay. This way and this way. Inclined, but same parallel to each other. Any distance, any value, not 100. See, for example, another couple. Body somewhere here, okay, of 50, not 50, 100, 500 Newton, 500 Newton. Now, distance is not 20, distance is 4 millimeter. Now, moment of this couple equal to 500 into 4 equal to 2000 Newton millimeter clockwise. Both are equivalent. Whether you apply this couple or that couple, effect on the body will be same. Both the effect will be to rotate, rotational effect of 2000 Newton millimeter. Okay, Newton millimeter. Okay, that is not an issue. Newton millimeter. or if there is one couple formed by two vertical forces, any but equal with any distance, and another couple formed by two forces in any direction but parallel and equal, unlike same condition, equal, unlike parallel, direction anything, by any distance, as long as moment of this couple and moment of that couple are same, both are equivalent, means you can replace this one by this one, replace the other one by this one. Anyone can replace the other one. The effect on the body, remember, not internal effect actually, deformation, no, rigid body action, engineering mechanics, we don't consider internal effect. The effect on the body remains same. That is the last principle. That is, any two couples of same moment and direction are equivalent. You can replace, you write here, you can replace any one of them by the other without having any change in the effect on the body on which it is acting. Okay, these are all the properties for a couple. Next class, I will take an example for a numerical part of the couple, and then the closing part, that is replacement of a given force system by a single force and couple. That will complete your part 1 finally. Then we are entering second part, that is equilibrium. The moment part 1 is over, notes will be ready. Thank you, I forgot.